In this video, I want to have a look at distance time graphs. So as the name suggests, these graphs represent the distance that an object is traveling over a period of time. Sometimes they're also called travel graphs. So let's have a look at an example. So here we have a distance time graph that's showing the journey of a cyclist and their distance from their home. So you can see that their distance was originally 0 and it goes up to 30. And the time that we're looking at, it goes from 9 a.m. to 3 p.m. All right, so let's have a look at these questions down the bottom. Question A asks us, how far did the cyclist travel in total? So in this first section of the graph, he's traveling away from home because his distance is increasing until he gets up to 30 kilometers from home, and then he has to ride all the way back. So in total, he's traveled 60 kilometers. Part B asks us when the cyclist has stopped. So again, if we look at this first section of the graph, you can tell that they're moving because as time increases, so as we move to the right, our line is moving upwards, so they're getting further from home. In this section here though, between 10 and 10:30, our line is flat. So that means that time is passing, but he's not getting any further away from home and he's not getting any closer to home. So we have between 10 o'clock and 10:30, he's stopped. But we also have this section along the top here. So anywhere that it's flat means he's stopped. So that's from noon till 1. So, and noon till 1 o'clock. All right, so there's 2 sessions where he's stopped, one for half an hour and one for 1 full hour. All right, question C says, when is the cyclist traveling the fastest? So we're ignoring these bits where he's stopped and we're looking at these 3 sections of straight line where he is moving, and we want to figure out where he's traveling the fastest. So if we're looking at speed, then we need to have a look and compare how far you've traveled compared to how long it took you to travel. So in this first one, it's taken him 1 hour and he's gone 20 kilometers. In this next section between 10:30 and noon, it's taken him an hour and a half and he's only gone from 20 kilometers up to 30. So that means this section, he's going much slower than this section. And you can actually see that without even calculating anything if we look at the gradient. The gradient of these lines tell us the speed. So because this section is steeper than this section here, that means that this section is faster. So that's only out of these 2 though. We need to look at this last one as well. And we can see that over 2 hours, he's traveled that full 30 kilometers. So that means if he's going 30 kilometers over 2 hours, that's the same thing as saying that in 1 hour, he would have gone 15 kilometers. And you can see that if you compare from this point here to this one here, that's a 1 hour time period, and he's gone from 30 down to 15. So that means that between 9 a.m. to 10 a.m., that's when he's traveling the fastest. Now question D is very similar to C, except it actually wants us to calculate speeds. To do that, we need to remember that speed is equal to the distance over time. So for our first section between 9 and 10 a.m., our speed would equal 20 kilometers because he's gone from 0 to 20, and that was over 1 hour, so 20 divided by 1, which would be 20 kilometers per hour. For part 2, our speed would be equal to, and we're looking between 10:30 and noon, so from here up to here. So he's gone from 20 kilometers to 30 kilometers, so he's traveled 10 kilometers, and that's in an hour and a half. That means if we put that in our calculator, we'd get 6.6 recurring, so we can just round that off to about 6.7 kilometers per hour. And then for part 3, we're going from 1 p.m. to 3 p.m., so that's 2 hours. And we can see that he's traveled from the 30 kilometers he was away from home all the way back to 0. So he's traveled 30 kilometers. So that would give us 15 kilometers per hour as his speed. So that's having a look at distance time graphs.